So let's take a look here at a couple more examples. I want the limit as x goes to infinity of e to the x over x. Well, if I evaluate that like I normally would to see what's going to happen, I end up with infinity over infinity. This is an indeterminate form. So this is equal by L'Hopital's rule to the limit as x goes to infinity. The derivative of e to the x is just e to the x. Derivative of x is 1, so this is infinite, therefore does not exist. So the limit as x goes to infinity of e to the x over x is in fact infinity. The limit doesn't exist because if you graph this function, it's going to shoot off to positive infinity. Now here's another example. It's the same as the other, except this time I'm going to 0, so x goes to 0 rather than to infinity. Here, if I do this, I'm going to end up with, well, let's just apply L'Hopital's rule. So if I apply L'Hopital's rule, I'm going to get the limit as x goes to 0 of, well, e to the x over 1. So as x goes to 0, this goes to 1, so this is actually equal to 1. So there's my limit. But not really, because there's a bit of an issue here. Actually, I just kind of went, yeah, that looks like it's going to be cool. It's going to 0, e to the x over x, apply L'Hopital's rule. But I did check to see if L'Hopital actually applied. Because see, if I evaluate this at x equals 0, what I get is 1 over 0. Okay, that is a little bit different. This is not an indeterminate form. Therefore, L'Hopital's rule does not apply. What I need to do is figure out what's going on here. So I need to take a look at the limit as x goes to 0 from the left of e to the x over x. Well, when I go from the left, what's going to happen here? I'm going to end up with negative values here. So because this x is negative and going to 0, and e to the x is always going to be positive, this is going to actually be equal to a negative infinity. This is going to shoot down to negative infinity. Also, if I take a look at the limit as x goes to 0 from the right of e to the x over x. Again, x is going to 0, but everything's positive, so this is going to go to positive infinity. So the limit does not exist. I'm actually shooting off to negative infinity from one direction, positive infinity from the other direction. And I can do a quick graph to show you that. This is what it's going to look like. See, as I approach 0, I'm going to be heading down to negative infinity. As I approach 0 from the right, I'm going to positive infinity. So the limit doesn't exist. But we would have not have known this. We would have claimed the limit was 1 if we blindly applied L'Hopital's rule without first checking to see if L'Hopital actually applies.